So I will today present you the Wiki Artificial Intelligence Search Engine project, short WAISE, that we at XWiki did for NGI search. So my name is Hamman. I'm a senior research and development engineer at XWiki SAS, the company that is basically sponsoring most of the work of XWiki. More on that in a moment. And my role in this project, but also generically, was the tech lead. Yeah, first, what are XWiki SAS and XWiki? That's a short introduction. I will keep this very short, and then I will show you what we did in this project. And the good part, main part, not sure, is I will try to present you some lessons learned, because I think that's the most interesting thing to learn from each other. Yeah, so what is XWiki? XWiki is a French independent company established in 2004. So we celebrated 20 years of XWiki last year. XWiki is not just a company, but also the name of this the open source knowledge management software that is our main product, so to say. It's an open source project. It's highly customizable. There are more than 900 extensions, and more recently, notable things is that we are part of the Open Desk project in Germany that is trying to build an open source office suite for the public administration, kind of, so web-based collaborative suite with email, with files, with everything kind of that you would expect. And we are part of that for knowledge management. So the idea is to combine existing projects, not to develop new stuff. The main advantage this offers is the integration. And we're also doing lots of Confluence migrations recently, to mention that. So that's where our main thing is, and was where basically the WAISE project is kind of situated. I will show this in a moment. We also developed CryptPad, that you might know. It's an end-to-end encrypted open source collaborative suite that a team in the company is developing. We earn money through support, training, consulting, cloud hosting, and of course research projects, as for example funded by NGI Search. And that brings me to the project. It was funded by NGI Search between September 2023 and August 2024, if I recall correctly or found correctly. It's already some time that we did this. And what we developed as part of this project as main feature basically is an AI chat that answers questions about content in an XWiki wiki or any other application. So we really try to build this in the spirit of NGI Search to be usable as a general search appliance also for other applications. I will show how this works in a moment. We focused on open LLMs, whatever that means. It's a bit fuzzy. But what in practice you can do is you can use any LLM that you can run somewhere or that somebody provides that has an OpenAI compatible API, which is the industry standard, and still the industry standard, which is quite nice that this is really showing some compatibility. The main technique that we used in this project is RAG, which is short for Retrieval Augmented Generation. I will explain this in a moment, how this works. We did not only develop this chat in XWiki itself, but we also made it embeddable in any web application. So you can take this chat widget that you see here, and you can embed this in another application. And also, even in the other application, we developed mechanisms to forward authentication information to take then access rights into account for the content. This is kind of what differentiates our project from like a standard solution that you can find somewhere else. Then we also did a benchmark of LLMs on this question answering task. That's basically the main goal, but we also did some comparisons on content summarization and content generation. We also made this chatbot available as a Matrix chatbot, so you can invite this directly into your Matrix chat rooms if you're using Matrix. Yeah, and if you want to try it, the extension is installable in XWiki 16.2 and later versions, because that's where the vector index was added, or the support for it. And yeah, but it's now old, so it's not really a limitation anymore. Back then it was kind of the most recent version, but now it's also in the LTS version. So how does this whole thing work? If you've worked with LLMs, I guess most of this stuff will look very familiar, but I still want to briefly present this. So we're all speaking about the same thing. So what we have is we have some application that contains documents. This can be XWiki, but it can also be another application. And these documents are submitted to WAISE, which is developed as an extension in XWiki. So for external applications, this is a REST API that we provide. And then we split these documents into chunks, into smaller chunks that are hopefully semantically coherent and also easier to digest for an LLM that might have a limited context size. This gets less of an issue more and more, but still more context size means more processing power, so you might want to limit what you provide to what's really necessary. And then we index this. We first developed only a vector search. For this, we compute embeddings with an embedding model that then allows to perform semantic similarity search. And later, we also use the standard keyword search in Solr in addition to that. I will show some results on that later. So we index this in two different ways, these chunks. This is the indexing side. And then when a question in the chat comes in, this is here at the top, the chat UI, it also has a JavaScript API in case you want to customize the UI, submits this to the XWiki server that also provides an OpenAI compatible API. And then we first perform here a similarity search. So we do both a keyword search for the question, and also we compute an embedding of the question and perform a vector search to get relevant context chunks. So to get relevant context or chunks, parts of these documents that are relevant for answering the question that the user asked. Then here are the access control checks. So from these chunks that we have found, we ask for every chunk, does the user have the right to view this chunk? And this can be internal XWiki, or we can also ask the original application. So we have their extension possibilities also to plug in custom access control checks. And then whatever passes the access control check is added to the prompt as context. And then we have this augmented prompt that contains both the user question and the chunks from the context, and we submit this to the actual LLM. As I said, this can be any OpenAI compatible model. This can be self-hosted. This can be hosted by Mistral in Europe, or also OpenAI if you wanted, Anthropic, whatever. They all have these APIs that are OpenAI compatible. And then we forward this to the user. So XWiki also kind of acts as a proxy here. And the user gets the answer. And you might not have seen it, but let me quickly show this here. We also provide here the sources at the top of the answer. So these are basically the URLs of the documents that you have. Okay, 2 minutes. Yeah, okay. I'm also done with the technical explanation. Yeah, what did we learn? Evaluations are difficult, but they're important. we think. So it's difficult to design if evaluation that finds meaningful difference between models. If you do it naively, you might see everything is the same. And you also need to account for randomness. When you want to ask what is a good answer, one possibility that we also use is to use an LLM as a judge to judge how good an answer is. It kind of works, but you need to know exactly what it is evaluating. We were kind of disappointed by the metrics that are provided by DeepEval, the framework that we used. And what we might reconsider is to build the evaluation right into the product, not as an extra tool, because we noticed that actually the evaluation is also needed by users or administrators to be able to evaluate their own prompts and to see how their prompts work. Yeah, and as I mentioned, we only had semantic retrieval first. It was not good enough. You need keyword search. I think I don't have really time, but what you can see here, it's all the same here with this metric that was provided, and then we did another metric and it's not the same anymore, and both metrics should kind of measure the same thing. The other thing I mentioned, we used RAG. RAG is kind of outdated already. The field is moving fast. What's the kind of thing to do now is tool use. That's the hot new thing, or deep search. Basically, not to provide context to the model with an external system, but more to let the model explicitly formulate a search query, then perform the search and give the results to the model and repeat until the model is satisfied. And the model context protocol is kind of emerging as a new standard here. And of course, there are new models constantly released. Yeah, so it's a lot of work to properly measure and fine-tune RAG systems. We noticed during the project that maybe the model itself, the LLM, is in some cases not so important. The RAG system or providing correct context can be more important. Testing is important to not to be fooled by first impressions. And yeah, doing an evaluation is worth it, I think, to understand the trade-offs that we have. And yeah, we see it's hard to keep up with the field. What we did basically is already outdated. I hope that we can update this. Our architecture should be kind of flexible to accommodate new things, but we also haven't found that much time recently as to work on this, as we were busy with other tasks that were also important for us. Thank you.
Okay. First of all, good day, everyone. Good morning. I'm Vijayasri, and I'm a machine learning scientist at PySchool. And today I'm presenting Trallie, which is the project that we are working on for NGI search. Now, Trallie, similar in spell, similar sounding, but different to a town in Ireland. Also, I'm told it's a fictional character, but that's how I would suggest that you remember it. And it's an acronym for Transfer Learning for Information Extraction. Now, just before I get started with, what Trallie as a project does, I'll just briefly introduce what PySchool is and what we do here. So PySchool was founded in 2017 by founders Isabel and Marco Trombetti. And they also founded Translated, which is one of the biggest language technology companies. And PySchool is a sort of spin-off. And it has basically two main verticals. One is the School of AI, where we kind of connect talent from all over the world and companies that are wanting to pivot to AI and set up this program called the School of AI, where the talent gets training and gets to work on real-world AI problems, and companies get really great quality AI solutions that they can use for their strategy. And so far, we've trained over 230 AI professionals and over 100 prototypes. The other vertical is our applied AI research. Basically, we work on projects like NGI and with other institutions like ESA. Maybe I'll just briefly show you some of those. This is the beautiful PySchool headquarters in Rome. You're welcome to visit if you find yourself in Rome anytime. Some of our AI projects. This is one of our most recent ones, which is with the European Space Agency. It's called Eve, Earth Virtual Expert, which is an AI-powered LLM assistant, and it's also completely open source. So we are planning to release a lot of artifacts related to Earth observation in the next few months. The second is Between. This is even older than Eve, and this is basically working on foundation models for speech. And the last one is one called the Collaborative Innovation Network by Esafi Lab. And here we actually not only support the technical aspect, but also the community building aspect, because we try to bring together researchers and talents that are in AI and also fields that are adjacent to AI, useful for Earth observation. And we set up a network so that they can collaborate with each other on innovative projects. And that's it. So starting with Trallie, let me quickly walk you through the problem. So a lot of relevant and valuable information is hidden in an unstructured or semi-structured form, so PDF, HTML. These things are, even semi-structured data is quite inaccessible, even though it is partially readable. And this information can be critical for your operations or business. But if you need to decode them or make them into a format that you can actually mine and understand, it requires a lot of domain expertise and countless man hours. Some examples of this, so these are the typical, let's say, sort of end user scenarios. Think you're a compliance analyst at a bank. You're trying to extract risk indicators in like reports that are PDFs, scanned documents. A computer scientist, you're trying to mine PDF research papers. Or you are an admin person, a non-technical person trying to extract data from invoices to do financial projections, or simply just logging details into an Excel sheet. Trallie is definitely something that you can consider using in these scenarios. And solution: can we make sense of these collections, these data collections, using search? And that's where the fourth open call of NGI comes in. Now, if I had to summarize Trallie, it is basically an LLM-based framework that offers agile information extraction from unstructured documents. The input will be an unstructured data collection. If you see the diagram, this is actually a semi-structured data example, because HTML is partially structured with the tags, but it's still not readable and searchable as easily as something like a table. So this is our ultimate aim. So to convert something like PDF, HTML, JSON, extract the data in an intelligent manner, and then produce it in an output like JSON, which can ultimately be read as a data set or a table that you can then proceed to use for your own use cases. Trallie is a modular framework. It consists of two separate components. These components can be used together, but they can also work just fine if used separately. Now consider the scenarios that I spoke about in the beginning. The compliance analyst or the computer scientist. They are what you call domain experts. So they know exactly what to extract from the data and what they're looking for. What if you're not a domain expert? And that's where the schema generator comes into the picture. So if you don't know what to extract from the data, but you're still seeking to understand what the data is about, the schema generator is this software component that understands or infers what attributes to extract, and then provides you a schema, which you can then edit or send directly to the data extractor, which basically takes values and then populates it into a structured format, which we can call as JSON, and it can ultimately populate the database. This is just a little bit of technical information. So let's say a schema generator gets an input as a collection of documents, and it will output the schema in the form of a list. So let's say an invoice. The schema would be, I extract the name, I extract the payee or the amount of payment, the date, So that would be what a schema would entail. And this is just the work through of it, which is basically parsing documents. For each document, extract important attributes and get the top K common attributes, because we are talking about collections and not a single document. Then the data extractor, of course, going through a document and then extracting the value from each attribute. This is all LLM based. So we're dealing with all LLMs at the backend that get this raw data and then give you the structured output. Now, just a couple of additional features before I move on to how you can use it. Trallie is greater than a model and, let's say, a set of prompts, because it supports several open and closed source models across multiple providers. So if you are wanting to use an OpenAI's GPT-4o, or if you want to use an open source llama that you don't want to deploy, you can use that. If you want to deploy your own model, yes, totally. If you want to use a local model without ever going to the internet, interacting with an API, yes, that's possible. And it handles data in several formats like HTML, PDF, text, and JSON. Most of our testing is happening in PDF and HTML, but and text, but we could expand that to other formats as well. The outputs are JSON validated. So if you are building software on top of Trallie, that should technically be possible, because you will get valid JSON that you can parse and use for your own application. And it had support for 5 EU languages, 4 of them being non-English, which is French, Italian, German, and Spanish, which are currently in testing. And all of this is completely open source. And I can tell you in a bit how you can access this. So currently, Trallie is working with prompt engineering under the hood. So the test release is predominantly based on prompt engineering, since models are already pretty good and you can achieve a lot just by prompting. But there are challenges that need to be addressed and improved. One is that this whole schema generation, extracting or understanding what to extract in a document, is a hard problem. And current models don't do it all that well. Data extraction is not scalable. Imagine if you had a set of 10,000 documents. You don't want to interact with an API 10,000 times and get a really fat bill that you need to pay just for this. So our solution to that we're actively working on is small LLMs trained on specialized data to allow local and scalable, extraction without compromising on performance. So this is something that we have started with the test fine-tuning on data that is synthetic, as well as some human label data, and we're optimistic about how the results will pan out in the next few weeks. And just a little bit about evaluation. Evaluation is pretty hard for almost all LLM projects where you don't have labels. So in this case, we did find a set of evaluation benchmarks from a sister project that is very, very similar to what we're trying to do. And we are trying to use that. And our metrics are F1 score based on an exact match, but also something called a synonym aware match, which is basically using embeddings. Because if models output in the schema, if they output name of lawyer and name of legal professional, they mean semantically the same, even though they're different words. So you don't want to penalize the model for outputting such diversity in schemas or values. So we take that into consideration. These are some initial results for you to understand what part works and what part needs improvement. Data extraction is already pretty good with the models that are open source as well as closed. This is a sort of embedding match that we did on a widely used data for information retrieval, which is FDA. And this is our evaluation as an entire system. You can see that between the last slide and this one, the accuracy came down by half. And this is why I said that, understanding what to extract from a document is actually quite hard. And this is what we want to tackle, in the near future. This is just our evaluation benchmark. In progress, many more data sets to be added. And yes, so to the interesting part. So Trallie is available as a demo notebook that you could technically use now. It's available as a repository on GitHub, which is under active development, and also available as a PyPy release. So technically, that means you could import Trallie and continue to use it as if you were a developer and want to use it for your use case. So what I'm showing is essentially this. Import Trallie, generate your own schema from a document, and then complete the schema or extract attributes based on the schema that you specified. This is from a legal data set. If I wanted to show you hold on, maybe I can show you a very, very short demo. So let me know if you can see my screen. So yeah, okay. So as you can see here, this is a very simple use case, which is basically uploading a collection of PDF resumes and asking Trallie to generate a schema and then populate it automatically. This is an overview of the entire system. Of course, like I said, you can choose to specify your own schema or use both of them, and it should work fine. So you can see this is a set of attributes that were extracted by Trallie. And I think that's it for the demo. Let me go back to the slides. And so upcoming details of Trallie, we are working on documentation. So that means we have a scientific paper in the pipeline. We hope to publish it in May or at least send it for review in May. One of the immediate use cases of Trallie is integration into our other project with ESA, that is Eve, where we plan to use the model that we develop as a backend for Trallie and expanding the use cases within Earth Science. Evaluation and benchmarking is in progress, and also implementing the fine-tuning. And lastly, we are in talks with our sister company Translated, which is gathering annotators for feedback data. So preference data is super important to get feedback on the performance of the models that we are developing. And that is exactly what we are working on. Lastly, we hope to present our demo at the NGI SearchCon, and and several open source events in the near future. And that's it. So thank you so much, and please feel free to connect with me as well as PySchool's social media and questions.
Okay. So thank you very much for this invitation. My name is Yannis Kopsinis. My background is on data science. I'm co-founder and CEO of Libra AI Technologies. And I'm going to talk about Mousse that comes from metadata-focused semantic search engine. A few words about Libra. We established in 2015 in Edinburgh, UK, but from 2020, most of the research development is taking place in Athens, and Mousse is developed here as well. We're a boutique data science agency that actually we focus in several machine learning applications, and basically take into account end-to-end development. So from research, developing the models, to deploy them in actual production systems. Now, regarding Mousse, there are two partners in the consortium, Libra, and also ICCS, the Essence Group of ICCS. And the goal is to enable LLM-based semantic search for data discovery, large data repositories, data portals. Actually, the setting in there is basically that data providers that own the data provide metadata with information about their data, and also a way to access the data for general public or scientists, etc. So the goal here is to adjust state-of-the-art document semantic search for structured documents to the metadata information. Regarding our experience in the field, we built LLM-based question answering systems for several organizations, for example, for the National Bank of Greece, for banking and legal domain, and also for maritime applications. And the major motivation for Mousse was the project Eiffel, Research and Innovation Horizon project that we participated together with ICS, that was the coordinator of that project. Now, we don't need to discuss much about the limitations of conventional keyword-based search. The user need to try again and again with several versions of their query in order to find their data. And however, it's not that simple when it comes to discovering data in data portals, and it's something that we realized through the Eiffel project, that actually there are certain challenges with semantic relevance and the name entity specificity. For example, the use case that I saw just for demonstration purposes has to do with air observation data. If a researcher asks for data, for fluid data for Paris, for example, they need to find something for Paris, or at least for France. However, semantically, so if one goes directly with an LLM, semantically, Paris is semantically similar to Rome. So if you just leave an LLM do the work, you will get fluid data, but for several countries and cities, and this is something to be prevented. And the same comes with the dates. If someone needs data for a specific time frame, they need to get data from this specific time frame. So there are semantics and entities in the query that need to act as a filter, not semantically using just an LLM. And another aspect that we try to tackle is the position bias consideration. We all know how tiring it is to go pages after pages to look for your results. So we want to enhance this part of the user experience. Now, the major contribution is first to provide state-of-the-art embedding LLM models in the domain, fine-tuned for the case. Actually, we embed separately the title, the description, the keyword fields of the metadata, and then fuse them properly to get the final results. Then to provide dynamic filtering, real-time dynamic filtering using name entity recognition. We have generated our very large data set for that, training an LLM to and the model to extract the several entities that need to be considered as filters rather than semantically. And we focus basically on location information and on time information. And also to provide a clustering, a meaningful clustering of the results, because someone can get, let's say, thousands of possible results. So to cluster them and explain them in a way that the user will be able to focus more easily and directly to what they're looking for, and also to have a good overview of all the information data that are available. So it is a quite complex pipeline to run it real time with dimensional reduction, K-means algorithm, and also a granularity that is adjustable by the user depending on their needs. And finally, to design a user interface that will simple, but to support seamlessly the above functionalities. Architecture-wise, I don't think I have time to go in details here. The idea is that we need something that actually works and then can handle asynchronously large loads of requests. Now, for the use case, just for demonstration, as I said, the development are not focused for this type of data. It is geospatial Earth observation data. It is a subset from data we acquired in the Eiffel project from the GEOS portal. And as I said, the developments here can be easily generalized to many other domains. However, if they have this, the spatial characteristics, it's data located in maps, etc., we have worked more to that, so they can be exploited better by Mousse. Now, I will go through a short demo. Okay, so this is Mousse basically. So let's say we make a query, air pollution data in London. Now the system automatically runs real time and realizes that London is basically United Kingdom, so it will filter out all data that are outside of United Kingdom. And when we say on March 2015, then automatically gets this information to use it as a filter as well. We have the results. Basically, this is the way that someone sees the data, and the data provider gives resources about the location that someone can find and download the data in the data portal. Dates can be handled in a very, let's say, a relaxed way. For example, if we say on summer 2015, then automatically the period goes to the 1st of June to 31st of August. During 2010s, the period goes to the whole decade. And the handy option is also to use a period without a specific date. So when you say summer, you will get all the data that are realized during summer, whichever year. And also more specific details, say from the 11th March 2011 to the end of August 2019. So it understands all this, and all this actually filtering is done in real time, which is not easy, I would say. Okay, and again, the experience someone gets when it uses some of the data. Another example. Greenhouse gases in Patras. Patra is a city in Greece, and Belgrade, and automatically understand that it's Greece and Serbia, but can also recognize areas, geographic areas as well. So it will say Balkans, Balkan countries. It understands all the countries, although Balkan is misspelled. It needs a K rather than a C. And if you see the results on the left, actually it has for CO2, CO, SO2, which are basically greenhouse gases, without this data set explicitly mentioning actually the word or the term greenhouse gases. The model knows that all these components, chemical components, are related to greenhouse gases and selects this data accordingly. And of course, someone can also manually adjust the period, the phase, and the country. So someone can use it directly like a search engine. I use a more general query to demonstrate the classification, because this is in a smaller data set. So if we see the cluster view, actually we see all the data that comes with query cluster together with the number of data that found. And of course, someone can press. And all these titles are also LLM generated to describe basically the data set, and also show, let's say, the central, the more characteristic data set of all these data sets. So we feel that this approach facilitates much the data investigation. Here is another example, greenhouse gas from boat. Again, here we see the results we get are from cruises, from weather station on board. There's not the word boat in any of this data. And in order to demonstrate another option that we have, basically to filter retrospectively our results in a specific area. So let's say that someone wants to get data, let's say, from this specific area. Okay, so we have this spatial filtering, and we focus only on the results found in this specific area. So, and these are the people in Libra that were working this nice project. Thank you.
Thank you very much, Yannis. See you at OW2Con in June. Is 17th and 18th, or the NGI Forum in June 19th and 20th. So, with that said, thank you so much for this talk and for sharing your projects. We look forward to following your journeys ahead.
Thank you.
Thank you very
you.
much.
Yeah, thank you.